All right, this is section 5.5A, and we're going to get more into solving equations, ladies and gentlemen. Okay, so here's 5.5A. These are more log equations that we're going to solve. Some of them you're required to not use a calculator. For example, these three, A, B, and C. Can you logically figure out how to do these without a calculator? Yeah, you can. So what you're going to want to do is try to rewrite them into whatever form they're in, write it in the other form. So for example, this one, write it in exponential form. So how do you write this in exponential form? 2 to the x power is 16. Now, one of the tricks is, can you get both of these in the same base? Yeah, 16 is 2 to the 4th power. So then you have this 1-to-1 rule where you can cancel those out and your answer is 4. Next. Rewrite it. 1/3 to what power is 9? Well, I want to get these in the same base. So what can I write 9 as? 9 is going to be 3 squared, right? And now, how can I turn this into 1/3? What would I have to do to this exponent? Make it a negative. There you go. And so what's your answer? X is -2. And guess what number you can't have in this spot ever, 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 ever? A negative or a 0. So this is no solution. Okay, again, try to do these. You're solving these for x. Example 2. Some of these are really easy here. Example 2a. How are you going to solve for x? You're going to rewrite this as what? 5 to the 3rd power is x. Well, what's 5 to the 3rd power? 125. How about b? 6 to what power is a 1? What is it? 0. And quickly, what's c? No solution. Because of that negative right there. Can't have it. And how about, what did I tell you when these two are the same? 1. Example 3. Here is an equation that we can solve. How are you going to solve it? You're going to rewrite it in exponential form. Tell me what the exponential form looks like. 3 to the 4th power is x minus 1. What is 3 to the 4th power? 81. And then what do you do? What's your answer? Now you could check your answer. You could put an 82 here. Subtract 1, you get 81. And is 3 to the 4th power 81? It sure is. It works. These are very familiar to us. We did these. All right. They're giving you the log of 2 base 7 is equal to that, log of 3 is equal to that, and the log of 5 is equal to that. Now, how are you going to get a 10 using a product of a 2, a 3, and a 5? Yep. 2 times 5 is 10. So now, what are you going to do here? You're going to add them up. So you should get the log of 2 plus the log of 5 you're going to substitute. Log of 2 is 0.3562. The log of 5 is 0.8271. Add those two numbers together, 1.1833. Easy. Next one, 2.5. I need to mess around with this number. Can I convert 2.5 to a fraction? What is 2.5 as a fraction? 2.5 or 5 halves. There you go. We've got a 5 and a 2 here. What should we do with the 5 and the 2? You're going to subtract them. The log of 5 is 0.8271. 0.3562. You get 0.4709. And the last one, 48. Let's factor 48. 48 is what? 6 times 8, 2 times 3, 2 times 2 times 2. So all these numbers multiply to give you 48. Is there a shorter way we can write it with a power? 2 to the 4th power times 3. So anyone have an idea what to do here? You're going to do 4 times whatever the log of 2 base 7 is. And you're going to add the log of 3 base 7. There you go. Questions? Okay, flip it over. Okay, what are you going to do to condense this? Let's do A. Condense A. So we are going to have, we have a product, and then we have a quotient. So these two you're going to multiply, and this one you're dividing. So to condense this, you're going to have the log. And the top, you have x plus 2 times y, and in the bottom you have x squared minus 4. Do you agree with that? And they're all base 7. Is there anything else you can do? Is it base 3? Oh, I'm sorry, because I'm blind. Base 3. What else can you do? Sorry, guys. Can you cancel something? There's something in here. I see something in here. Oh gosh, x plus 2, x minus 2, right? These are bye-bye. And so your answer is, and you know, I'm showing every step. Some of you guys can cancel this in your head, and I'm fine with that. You're at a point where you've earned that right to skip a step here and there. Here's your answer. Okay, next. This one's a little tricky. You've got 3 minus, I'm going to rewrite it here, 3 minus all right, is there any way you can rewrite this 125 with a base 5? Mm-hmm. Now, this can be expanded right here. This piece right here. This is really 3 minus the log of 5 base 5. And then you have 2 minuses here. You have a product. you have here. Now, do you know what this equals right here? This equals 3, yep. This 3 goes in front, and 3 minus 3 is 3 minus 3 is 0. So this is all gone. So what you have here is negative log of x base 5. Now see this 1 right here? Can you back this up here? This is a negative 1 power. So it's really x to the negative 1 power, or another answer would be make it a positive x. Those are both the same. This is the tricky part, is this minus sign, and you have a product here. So both of these, think of these in the denominator of this fraction. That's why this is where it's at. Questions? Okay, this next section, change of base formula, is super easy. I'm going to show you how to do these on both calculators. So, when you have, if I were to convert this into 8 to what power is 9, I can't do this without a calculator. So if they gave you that problem or this one, you need a calculator. You can't convert these both to base 8 or both base 9. So you're going to use a calculator. If you're using the Inspire calculators, when you type the log button on your calculator, which we talked about, there's going to be 2 boxes. Okay? The 2 boxes, you're going to be able to type the 8 in here, put your 8 in there, and then you're going to use that keypad in the middle and scroll over here and get your 9, and then hit enter. And your answer is 1.057. If you have the old calculators, and a lot of you guys still have them, these ones right here, what we do is use the change of base formula. So what this looks like is, you're going to do, does anyone remember before I tell you? Remember how to type this in your calculator? You type, it's the change of base formula. So you're going to type in the log of 9 divided by the log of 8. Anytime you have 2 numbers here, you type the log of 9 divided by the log of 8. And you get the same answer. Okay? Easy stuff? Okay, and number 7 is review as well. I already taught you this, but I'm going to go for it again. I want you to describe the transformations, and then we're going to sketch a little graph. How do you go from here to here? Do you remember there's 2 transformations? This is 1, and this is something. What does this plus 1 do? Shifts it what? 1 unit to the left, and this is going to be 3 units down, right? So now, how do we get more specific and graph the actual problem? Well, this is 2 to the y power is x. So give me the parent function here. That's the parent function. Give me the t-chart. Remember the t-chart that we do? We're going to plug numbers in for y, like -1, 0, 1, and 2. And when you plug a -1 here, you get 1/2. When you plug a 0, you get a 1, a 2, and a 4. Remember this? Now let's do the transformations. This should be an easy one. So what does this plus 1 do right here to our table? The plus 1 does this right here. You're going to take your x values and do what? Anyone? Subtract 1. Take these x values, remember you do the opposite here, subtract 1. So if we subtracted 1, what's 1/2 minus 1? -1/2. What's 1 minus 1? 0. What's 2 minus 1? And what's 4 minus 1? 3. Now the next step, right here, what does this minus 3 do? You take your y values and you do what? Subtract 3. So subtract 3, what do you get? Subtract 3. Subtract 3. Subtract 3. And guess what these ordered pairs are? Your thing. Your thing. What's your thing? Here's your thing. You're going to go over, let's say that's 1, over a half and down 4. Over 0, down 3. Over 1, down 2. Over 3, down 1. So it looks like this. This is the best I'm going to do freehand. Now, do you know there's an asymptote? Do you know where it's at? Right here. It's x equals -1. So the graph is going to get closer and closer to that imaginary line, x equals -1, and never cross it. What that's going to help you find is your domain. Your domain on this problem is going to be all the x values that are greater than 1 because of this. They're going to be greater than 1. And what's your range? All real numbers. Easy? Okay, so, dun, 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 dun. Here's your homework. You're just going to do the odds. I want to do one from each section to start you guys off to show you how easy these are. Because it looks like mumbo jumbo. The first 8 problems. Read the directions. It just strictly says translate. It's a translation problem. That's it. Number 1, how are you going to translate this into log form? It should be very easy. How do you translate that to log form? How do you translate this? The log of 0.01 base 10 equals -2. You guys got that? Log 0.01 base 10 equals -2. Now, do you need this base 10? No. If it's base 10, you can eliminate, you didn't have to write that. You could have just written the log 0.01 equals -2. Okay, skip to 11. How do you translate this into exponential form? What's the base here? What's this base? It's 10. So this would be 10 to the 4th power is 10,000. Easy? Okay, next one. Go to 21. These ones are asking you to evaluate. So you might have to do some toggling back and forth. Some of them are easier than others, like this one, 21. The answer should scream out at you. What's this base and what's this number right here? These are both 10s, so what's your answer going to be? Square root of 43, because that goes in front. So for 21, it's the square root of 43. Go to the back page. 29, and remember, just do the odds. Do the odds. They want you to fill in this T-chart here. So they give you this equation, y equals the log of x base 4. Me, I have to convert this to exponential form. I have to convert this to 4 to the y power is x. Now they're saying if x is 0, if I put a 0 right here, can you think of a number that y would be to get you a 0 here? There is none. You can't do this one. This one's undefined. You'll never be able to take 4, raise it to a power, and get a 0. What if I put a 1 here? 4 to what power is a 1? 4 to what power is a 1? What number would this be, this y value be to get a 1 here? 0. Yep. That's a 0. How about a 2? 4 to what power is 2? A half, good job. In this last one, 4 to what power is 4? 1. So that's how you're gonna do those. And by the way, these are all in your book. So if you have your book, your answers are in the back of the book. Okay? 37 and 38, you're gonna use your graph. They want you to find B. I'm gonna let you figure that one out on your own. You're gonna plug these numbers into this table, into this equation, to see if you can figure out what B is. You're gonna try one of each of these points, plug it in and see which one logically makes sense for what B is. Not that hard. For 41 through 45, you're gonna solve these equations. How do you solve an equation of this nature? 3 to what power is 243? Anyone know? 3 to what power? You're gonna turn this to 3 to the 5th power. So that 1-to-1 rule, x is 5. So that's how you do these. And then the back side, it's writing it as a single log. So look at 47. It looks like a lot more than what it really is. For 47, how would you write this as a single log? This 2 is going to be this power, this 3 is going to be this power, the 6 is going to be this power, and that's a division problem, and that's a product. So how would you condense this whole thing? It'd be the log, and they're all base 10, so you don't need that 10. On the top, it's going to be x squared y cubed, and on the bottom, it's going to be z to the 6th power. Just like that. 61 through 66, you might want to do those quickly because you have your if you don't have a calculator. This is just using the change of base formula. You just type in either, if you're using the old calculators, you would type in the log of 10 divided by the log of 2. If you're using the Inspires, you just type it in, you type in log, and you put these two numbers in the right spot. And 61 is 3.32. And then for 69 and 71, which all you have to do is describe the transformation. So what should you do with this 3 right here? This is an old school problem. What should you do with the 3? Pull it out. You pull this 3 out, don't forget. Remember that? So this is going to be a horizontal compression by 1/3 and then 4/3 units to the right. And we worked with those, we did a lot of those. So this is your homework for this weekend. Yes, you have homework. Try to get these all done. Just do the odds up to 71. And I just did like, what, 7 of them for you?